Okay, so here's a problem that came across my desk. This is a relatively simple system of linear equations, or linear system for short. You get this probably, second year high school, integrated math 2, something like that. So how do I solve a system of two equations with two variables? We have u and z. In this case, both equations are already written in standard form, which happens to be my favorite. So there are, I don't know, about 3 different reasonable ways to do this, 4 if you count matrices that you probably won't learn about. But anyway, my favorite is the elimination method for something simple like this because it's the quickest and the fastest. So I'm going to show you how to solve this simple linear system using the elimination method. Okay, so the first step I want to do is put both equations in standard form. Done. They were given to me that way. The second step I want to do is to make opposites. And I can do that through multiplication. There are basically infinitely many different ways that I could do that. For example, I could multiply this top equation by -2. That would make these two terms opposites. I could multiply the bottom equation by -3. That would make these two terms opposites. Which variable do I want to eliminate? I'll go ahead and do the -3 because I kind of have a little spot there to do that. So I'm going to multiply really the whole equation by -3, or you could call it multiplying both sides by -3. Either way, I'm just going to multiply every term of equation number 2 by -3. So I'm going to go ahead and recopy the whole system, starting with the first equation, which is 3u plus z equals 15, and my second equation distributing that -3 to every term in the entire equation. -3 times u is -3u, -3 times positive 2z is -6z, and -3 times 10 is -30. Okay, now I have my opposites here. These two terms are opposites, and that was my goal. So the third thing I'm going to do is eliminate. What that means is I'm going to add these two equations together vertically, like an elementary 3-digit addition problem. And because I made opposites, according to the inverse property of addition, when I add opposites, they cancel out to 0. And it's not necessary for me to write the 0 because 0 plus whatever is just whatever. And so now I've got the positive 1z. Don't forget the 1 there. I should probably write that in. We often forget there's a sort of silent coefficient, a default, I like to call it, of 1. If there's no number written in front of a variable, it's a 1. So we've got 1z and -6z. That's going to make -5z. And I know my z's don't look great, but that's why I cross them. And on the right-hand side, we've got 15 minus 30, which is, I didn't write that very well, -15. Hopefully that shows up. Yep, I'm using markers here to make them show up for the camera, so use pencils at home so you can erase your mistakes. Now I'm going to divide both sides by -5 to cancel out the coefficient. And that's going to give me z equals 3. Now I'm not done. I have solved for one of my two variables. Okay, so that was the next step, was to solve. I didn't mention that. I eliminated and then I solved. So I made opposites, then I eliminated, and then I solved for one of the variables. Now my fourth step, I'm going to substitute the value for the variable that I have solved back into either one of the original equations. It does not matter which one, as long as it's one of the original equations. And so I'm just going to copy this first equation, 3u plus z equals 15. I'm picking the first equation arbitrarily, no great reason for that. And now that I know z is 3, or at least that's the value of the variable that makes both equations true in this case, I'm going to substitute that in place of z in one of these original equations. And that's going to give me 3u plus 3 equals 15. And now I'm going to, step 5, solve again. So I'm going to subtract 3 from both sides. So this is generally a 5-step process. And that gives me 3u equals 12. That was moving my constants to the right, by the way. And then I'm going to divide both sides by 3 in order to cancel out the coefficient. And that's going to give me u equals 4. So, time to write my solution. My solution is an ordered pair in alphabetical order. U comes before z, 4, 3. That is my solution. That is, in algebraic terms, that is the ordered pair of values for the variables that make both equations true simultaneously. In sort of geometric or graphical terms, this equation makes a straight line and this equation makes a straight line. That's why we call this a linear system. And if we were to graph those two equations on the same Cartesian coordinate plane, they would cross at this point. Or in other words, these are the coordinates of the only point that is on both lines at the same time. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.